This is a video on functions written in APL. It is about the function from MS, a little function that takes a matrix of strings as argument and turns each one into a number, effectively returning a matrix of numbers. It is written as a defun in Dialog APL. It was written for a video on how to solve simple Kakuro puzzles. If you are interested in Kakuro, here is a link to it. Basically, the left and top edges of non-empty cells represent clue cells, and all the other cells are where the puzzle has to be solved. The argument to from MS, the matrix of strings, can be entered manually or using, for example, Excel. Let's do that. We'll take Excel. I have created a little puzzle here. 7 is the total that must be in these 3 cells. 13 is the total that must be into these 2 cells. 4 is the total that must be in these 2 cells. And this one is just an empty cell where we can't play. So let's take these. Let's use copy. And let's go back to APL. Let's create a variable called P43 for puzzle 4 lines, 3 columns. And paste into it the contents from Excel. Let's have a look at it. Okay. With boxing on, we can see the cells better. Now let's have a look at the result of from MS. It is a table of numbers. As you can see, each string has been turned into a number. If the string was empty, it was turned into a 0. All the other ones have a non-zero in them. Either a single -1 if the cell is not to be solved, or a complex number denoting the sum, vertical and or horizontal, of the group after it. Let's trace through the program. The first thing we do is to create the top and left edges with -1, because we know there won't be any cells to solve there. We use the shape of the argument, the matrix of strings, to create 2 Boolean vectors, and we insert jot.or between them. This creates a Boolean matrix with 1s on top and on the left hand side. We then change the sign of each one of the elements, and the final up arrow is to disclose this result, to remove one level of nesting introduced by insert, the slash. On line 3, we verify if a backslash or an X is in each string. The or/membership is an atop, a 2-function train that returns a 1 if any of the left argument, here backslash and X, are in it. By the way, if you want to know more about function trains, you should see this video here. This could have been rewritten this way, or like this. They are all equivalent. Function trains are recent in Dialog APL and are pretty efficient. BS now contains one where an X or backslash is in the cell. On line 4, we adjust M appropriately. It will contain a 0 where a cell has been filled, or a -1 if not. BS is a matrix, but we will need it to be a vector below, so we ravel it using comma. We turn it into a vector. On lines 7, 8, and 9, we define a local function that will be used on line 11. The function will take a single string as argument and return a number. Because the argument may have come from Excel, line 7 removes any nulls from the argument, omega, and ensures with Thorn that it is a string in that case, otherwise QuadVFI, which is used on the next line, would complain with the domain error that its argument is not a string. Let's see why. EAN is an empty array of nulls. If we try to use it with QuadVFI, QuadVFI complains. So we have to Thorn it before. We have to format it, turn it into a string. On line 8, we use QuadVFI to turn str into a pair of numbers. The way QuadVFI works in Dialog is to change any string representing a number into a number and any other string into a 0. So here, if we try QuadVFI on the string ABC space 321 space 2.3, QuadVFI returns 2 lists of numbers. The first one is a Boolean, a mask, that indicates if the corresponding element in the second list is valid. As we can see, the 0, 1, 0 to the left tells us that ABC is not a number, that 321 is okay, and that 2.3 is not a valid number. Used dyadically, that is with the left argument, it uses the left argument as delimiter. this is handy, for example, with CSV files. By the way, if you want to know how to process CSV files in APL, see this video here. So here's an example of dyadic QuadVFI using comma. We can see that they are all valid except the 2A34 there. Note that even though there are no actual numbers between two consecutive commas, QuadVFI consider there is a valid value there, a 0. This comes in handy for us as we use the backslash as left argument to QuadVFI to find which sums were entered in the clue cells. So QuadVFI with a single backslash returns 2 valid zeros. With a backslash and a 7 returns 0, 7. With a 21 followed by backslash returns 21, 0. And with a number on each side of the backslash, it returns both numbers. We don't care about the mask, so we ignore it and use the expression pick flip to get the second list. We make sure we have two elements which we store in V, and if they are both 0, we return -1. If they are not both 0, we turn a 0 into a -1 using the expression V minus 0 equals V. 0 equals V will be 1 if it's 0, and V minus 1 will only happen if V is a 0, thereby turning a 0 into a -1. And then we assemble both numbers into a complex number using -9 -1 plus dot circle. -9 circle leaves the number as it is, and -11 circle turns a number into an imaginary number by multiplying it by 0j1. This is the same. Here is a way to do both numbers at the same time. The plus adds them up using insert, slash, or inner product. This could have been written like this too. So this convert function works for quadnulls. It works for a single backslash, or for a number followed by a slash, or for a number following a slash, and for two numbers separated by a slash. All we need to do now is on line 11 to turn this function on each of the cells of the argument that needs to be converted, and return m as the result on line 12. And that's it. Hope you enjoyed. See you later.